and I am going to explain the steps of the standard deviation calculation. Usually we use statistical software, perhaps Excel, to calculate standard deviation, but you are required to understand in biology how to do such a calculation by hand. And there are several steps involved, and it is easy to make a mistake, so it is best to do the steps slowly, double check your work, and then you are more likely to get to the right answer. So in this example, what we're going to be working with is I went to Google and I found some tall volleyball players. I chose about 6 of them here, you can see, and wrote down their heights. And you'll notice that these heights are not in metric units. In fact, these are in feet and inches. If you are not aware of that, the inch measurement system is not part of the metric system. So whenever we work in science, we actually prefer to measure in metric units. So we're going to have to do a conversion. We're going to have to convert these lengths to metric units before we can continue our calculation. So let me do an example here, then you can see if you can work ahead and do the rest of them. If we know that Mussorgsky's height is 7 feet and 2 inches, and we use this conversion scale here of 1 foot is equal to 12 inches, then we of course are going to say 12 times 7, which is 84, plus those 2 inches over here will give us 86. And then of course we have to still multiply that by 2.5 to get to centimeters, because we now have it as 86 inches. So let's multiply by 2.5 for, and then we get our answer. So 86 multiplied by 2.54 is 218.44 centimeters. So you work with me, see if you can get to the other units, metric units for this list of volleyball players. I'll explain as I go along, but if you're faster than me, go ahead and work. So we know 7 feet, we have to multiply by 12 again, we get 84, and now we just add 1 inch. So it's 85 inches times 2.54. So this gives us 215.9 centimeters. 7 feet exactly would be 7 times 12, and that's going to be 84. And then we multiply 84 times 2.54 to get 213.36 centimeters. Next up we have 6 feet, so multiply 6 with 12 to get 72, plus 9 inches, so that's 81, and then multiply that by 2.54. That's 205.74 centimeters. And then 6 times 12 is 72 plus 8 inches, 80 times 2.54, 203.2 centimeters. And of course this one's going to be the same as that one. No need to recalculate that unless you want to double check your work if you think you made a mistake. Now, in a standard deviation calculation, we are interested in seeing how much deviation from the average height do we have. So the next thing we have to do is to calculate the average height. X bar is going to be our average height. So in order to calculate average height, you have to go ahead and add these 6 values together, and of course divide by 6. So take a moment to do that. you make a mistake, start over. I make mistakes, I start over. It happens. So divide your answer there by 6, and then you can round to 2 decimals, right? We always prefer to round to 2 decimals in biology. So there we go, our average height is 209.97. Next up, we're going to use this formula you see down here. This is the standard deviation formula. I know it may look scary, but let's look at what each individual symbol means before we move on. This big E stands for sum or total. Then XI stands for individual height. Of course, we're going to use metrics. There is the X bar. We just calculated our average height. N is the sample size. And what we can actually do is we can put D here in the middle, because D would be to replace this value that we calculate, the individual height minus the average height. So now we have to, for all 6 of these athletes, calculate D squared so that we can plug that into the formula. So what we're going to do is we're going to move to a new sheet of paper, and we're going to take our individual heights. So there's our first one, 218. I'm going to quickly jot them down so we have them here to work with. And number 6, there we go. And we have to calculate D squared, we said. So we're going to take this individual height and we're going to subtract from that then the average height. So we will do it in this fashion. We'll say 218.44, subtract now the average height from it, and do the same for all of these values, right? For each individual athlete, you need to calculate D squared. Now you'll see it's important that you have calculated that average height correctly, because if you miscalculated the average height, from this point forward your answer will be incorrect. Now you'll also notice that you may end up with a positive or a negative number. For example, if we do 218.44 minus 209.97, we get 8.47, right? Keep going. Let's do them all. Let's see what we end up with. 215.9 minus 209.97. And the next one. Now you notice you end up with a negative number. That's fine. Keep going. Of course, this one is the same. Now, this has to be squared. So how do you square a number? You write it like this. You can either use on your calculator the X2 button. Let me pull this in here. Look for a button that looks like this on your calculator, and you can type in 8.47, for example. Squared, press that X squared button, enter, and you get a value there that says 71.74. Again, we round to 2 decimal numbers. So you keep going, you do the same for the other values. 2.93, you press that x squared button and enter for the answer. Now when you square a negative number, that negative sign disappears. It becomes positive. So you can just leave that out. And there we have our d square values. We have to add them all together. We need to get the total. Remember at the top of that formula, there was that big E. That means we have to add all of these d squared values together. So let's go ahead and add them. And I come to 227.94. If you think you made a mistake, redo your work. It's not going to be a waste of time if you know you're going to get to the right answer, right? All right. So now we have to go back to our formula. Remember, our formula looked like this. We had our d squared total up here, and we had n minus 1 underneath it. Now remember, n minus 1, n here stands for sample size. We started with 6 athletes. So what we can plug into this formula is the following. We can put our value 227.94 on top. This is the sum of d squared. And we can put 6 minus 1 on the bottom, which of course, if you simplify this, would be 227.94 over 5, and we still have to get the square root of that value. So let's go ahead and divide 227.94 by 5. We get 45.588, and at this point I think just leave it. It's not such a big number. And of course, to get the square root, you have to use that square root function on your calculator. So look carefully. It probably would be a second function on your calculator as well. It's a second function here on my calculator. So I am going to press second function square root. It wants me to type in that answer. So I probably would have to do 0.588 rather, inside of that square root, and then get the answer, which solves to 6.75. Put in your metric unit, and that is your final answer. The standard deviation is 6.5 centimeters. Now, what does that mean? If you go back to your original data set and you look at the tallest person, Muserski, and you look at the shortest person from that list, Bertona, that implies therefore that they deviate 6.75 centimeters from the average. That's the standard deviation, right? The average, remember, we said was 209.97 centimeters. So you're going to have a deviation of 6.75 centimeters above this value, and you're going to have a deviation of 6.75 centimeters below this value. And that's how you calculate standard deviation.